Hello everyone, I'm Alexis and this is Jaume, and together with Jordan and Oscar, we present to you E-Trace, which stands for European Tourism Regional Analysis and Climate Effects. And here's the central fact we start with. So Europe is warming, like the whole world, and the temperatures are rising. And the Köppen-Geiger climate zones, you can see here in the two screenshots, it's like a standardized, mainly used climate classification system, and it defines what you experience when you basically visit a region. And that is shifting in the next couple of decades. So now the question is straightforward but hard to answer. And which regions will gain tourism appeal and which will lose it as a result? And you see, tourists don't just book based on temperature, they book because they want a specific climate experience. So for example, the Mediterranean summer or the Alpine winter. And as those zones move, so does tourism demand, and that created our target variable, which is overnight stays, tourism overnight stays. And our actual research question is, can we predict how tourism overnight stays will shift across European regions under climate change scenarios? And we're not just speculating, we're building a machine learning model trained on real historical data, mostly from Eurostat, a very credible government source from the EU. And we want to learn how climate shapes tourism demand. So we're gonna hop into our live demo. And our historical data mainly consists of 100 years back from 1901 to 2020 temperature data, but also some recent variables, like for example, you can here see a small description of the Köppen-Geiger climate classification. And here you can choose a specific region in Europe. So it's based on the NUTS2 regions. It's like a classification system for regions in Europe. And we chose here Andalusia. And you can see a small data preview of all the historical data we trained it on. We plotted some graphs across the years, how it changed. For example, here GDP per capita or employment or even temperature. And now we come to the more exciting parts of our dashboard. So the mapping of the whole regions. And you can, for example, take GDP per capita here and choose a specific year. And it then shows us all the years and the GDP per capita for the region, how it evolved. And also we made some neat map to compare to other regions. The more darker ones are a little bit on the lower side, and the more warmer colors are on the higher side. You can compare different NUTS2 regions. Let's hop to the core part of our work, which is the model. And it will take a little moment. And here we have it. So the first parameter you put in is the scenario. So there might be a worst case where Trump says, let's go all into coal plant building, and China and India does it as well. And let's go out of EVs, for example. That would be like the worst scenario. So temperatures rise more. And we have like a best scenario case, which would be that we all go into EV, we invest into renewable energies, and we find like somewhat the middle ground, which is like 2.5 degrees across the next 50 years. And we chose again Andalusia just for reference, and choose a year again, let's say, and then you can see the region itself, where it is located as a first map, and our prediction, which our model predicts, which is 49 million. That is a really high number, as you can see in the second map. So the highest value of all the NUTS2 regions is 65 million, and the average is 9 million. So Andalusia has a lot of tourism, and as you can see, we've made a 3D stacked bar plot on top of each region, which really shows the absolute number. So here you can see there are not many ones that are bigger than Andalusia, and you can hover around and look at different values. And here is a map of the change of each region. So you can see pretty good, well, how it evolves. So which region gains a lot of tourism through climate change and which loses some. So for example, here Andalusia is really green. Some Central European regions are kind of red, or some Northern German regions. And yeah, that was our demo. For now, I'm gonna hand over to Jaume. He's explaining a little bit about our model. It's XG Boost.
Hello everyone, I'm Jaume, okay, and I'm gonna talk a little bit about our model, which was HGB, which stands for Extreme Gradient Boosting, okay? It's a decision tree ensemble method, and the idea is pretty simple, okay? The first tree makes an initial prediction, and each of the following trees are trying to reduce that error, okay? So basically we choose HGB because it provides a very good performing out of the box and also handles very well with nonlinear relationships as climate and economic stuff processed within. And also it's very efficiently working with large data sets. So for example, let's think that in our project, each race we're trying to predict overnight stays only based on the temperature. Okay, so the model is able to give predictions even with temperatures that it has never seen before. For example, you can notice that we didn't have data from France, that because France didn't regulate much to region data, but we were able to make predictions because the model was able to generalize. Okay, you can think also in the HGB model like a group of friends when you are trying to decide where you're going to have lunch, the restaurant. Okay, and so the first friend says, let's go here. But the second friend comes and looks and says, okay, the restaurant is not going to work because, or another friend is vegetarian, so we can go there. I propose another one. Okay, so the third friend comes and says, okay, this one is not going to work also because it's close, and so on and so on. So HGB is always looking on what the previous tree did wrong, basically. If you want to know any more technical details, I will be very happy to explain to you. But for now, Alex is going to tell you about our findings.
Yeah, so what did the model actually tell us? So the first one is southern coastal regions like Andalusia or Catalonia show significant positive growth, and in overnight stays. Despite warming, the classic sun and beach model remains robust. And the second one is inland regions. Think central Germany, the continental interior face significant declines in projected overnight stays according to our model. And growth concentrates in a subset of regions, like the Mediterranean coast, southern areas. Meanwhile, many interior regions see stagnation. And by 2041, just 16 years from now, tens of millions of overnight stays are going to be redistributed. And so it's kind of like European geographies being redrawn by climate and tourism, therefore. And thank you for listening. If you have any questions, feel free to ask after the next one.
You can look at followings for 2050 if you go to a page, maybe. We'll be able to, but don't collapse the page, please.